Hello everyone, in this video we will talk about the economics of renewable energy. Engineering economics. It measures the cost and benefits of an engineering project to determine if it may or may not provide cost savings to guarantee its capital investments. So engineering economics helps to decide if a project is worth launching or not. It determines if the project can be supported financially and if it is profitable. Economic analysis calculates the overall cost of a project during its lifetime and compares the cost of competing projects and technologies. It, it evaluates the cost and benefits and the welfare impact of a project. The results of the analysis will decide the implementation of the project. One of its useful applications is determining the payback period for a project. Payback period is the amount of time it takes to recover the cost of an investment. It is a method to calculate investment returns. It determines how long it takes to recover the initial cost associated with the investment. So the shorter payback period, the better. Capital or initial cost. It is the project's initial investment, which may include labor and other costs incurred at the beginning of the project. Operating and maintenance cost. It is the expenses that keep the system running in proper condition over its lifetime. So it is the total amount of expenditure for the system stays in shape. It can be fixed like regular maintenance costs or varied like electricity costs. Salvage or scrap value. It is the estimated resale value of an asset at the end of its lifetime. So it is the amount for which an asset can be sold at the end of its useful life. For example, this car. The owner of this car can sell it for a certain amount, and that amount is the salvage value. Cash flow diagram graphically depicts the time of the cash flows. So the horizontal line represents the timeline, and the vertical lines represent the cash flows. The downward arrows are the negative cash flow, indicating the expenditures, and is known as outflow, while the upward arrow is the positive cash flow, indicating the incomes and is known as inflow. The time value of money. The value of money changes with time due to interest and inflation, among other factors. The value of money may increase or decrease over time. It may increase by depositing the money into a savings account to earn interest or invest it, and it may decrease due to tax and inflation. Here's an appropriate economic analysis to consider how the value of money changes with time. Using the compound interest formula, we can determine the future value of money, in which F represents the future value of money, P is the present value, I is the interest rate, and N is the number of compounding period. The formula shows that money grows exponentially over time, and this is known as compounding. So in compounding, when the earned interest is reinvested back into the principal of an investment, the asset's value increases exponentially over time. As an example of the application of the compound interest formula, assume you deposit $1,000 in a bank account that pays an annual interest rate of 6%. What is the value of this amount in 4 years? So the given in the problem are the $1,000, the present value of money, the 6% interest rate, and the time of 4 years. Using the compound interest formula, we substitute all the values in the equation and compute for the value of f. So we get $1,262. So the value of $1,000 in 4 years is $1,262. Another example, Alexa has loaned an amount of 50,000 pesos to the bank with an interest of 8% compounded monthly for 3 years. At the end of 3 years, find the amount Alexa has completely paid in the bank. So in this example, the money is compounded monthly for 3 years. In this case, we divide the interest rate by 12 for the monthly interest rate and multiply the 3 years by 12 for the compounding period. And then substitute all the values in the equation and compute for the value of f. And we got 63,511.85 cents. So at the end of 3 years, Alexa paid the bank 63,511.85 cents. Present value of a future amount. To find the present value, transpose the future interest to the other side, and we got the formula for the present value of a future amount. Uniform series amount of a present or future value. Uniform series amount is the periodic income or expenditure. To determine the uniform series amount of your present or future value, these formulas are used. This one is for determining the present value, and the other one is for determining the future value. Effect of inflation and taxation on interest rate. Inflation. The purchasing power of money declines over time as the price of goods and services rises. So, when prices rise faster than salaries, inflation occurs, resulting in a loss of purchasing power. It takes more money to purchase the same amount of goods and services. Therefore, the value of money is decreasing. Taxation. It refers to the fees and financial obligations assessed by a government on its citizens. So it is the paying of taxes. It applies to all payments of mandatory taxes, including on income, corporate, capital gains, property, sales, and inheritance. Inflation-adjusted interest rate exists when both interest and inflation occur at constant rates. Inflation taxation adjusted interest rate exists when interest, inflation, and taxation on the interest occur at the same period at constant rates. By using these formulas, this show that inflation and taxation decrease the original value of the interest rate. As a result, the value of money also decreases.
Hi everyone, so let's now discuss the life cycle costing analysis. It is also known as whole life costing, and it is the process of estimating how much money you will spend on an asset over the course of its useful life. So just to give you an idea, it is also used especially to select the best project when there are multiple projects that satisfy the same performance requirements but differ in terms of operating costs. So the main purpose of this analysis is to estimate the overall cost of a project options and then select the designs which can ensure the facility to provide the overall lowest cost of ownership constant with the function in its quality. So it is also recommended to perform at an early stage so that there will be chances of refining the design to ensure the reduction in life cycle total cost. So as you can see here in the slide, we can definitely calculate the asset of life cycle cost with the expenses of the estimated details below. So first is the initial cost. Second is the recurring cost where the operating cost and maintenance expense is already included. Disposal cost and residual value. We also have here some simple formula that we can use in computing the life cycle cost analysis. So LCC stands for life cycle cost formula equals to C, which is the 0-year construction cost, plus PV recurring minus PV residual value. So we have here an example, and we have Mr. A that wants to purchase a printer for his business purposes. So the printer costs $2,000, and we all know that printer needs more equipment and maintenance for it to function and to last. So for the installation and delivery, it costs $50, estimated $900 for ink and paper, $300 for their electricity, maintenance for around $500. And since Mr. A financed the printer monthly, there's a credit card interest rate of 4% per month. Depreciation value will be reduced by $100 each year. And lastly is the disposal of $150. So as you notice, the printer only costs $2,000, but the life cycle cost of the printer will end up costing the business more than $2,000. So we have here the purpose of the life cycle cost analysis. First is we can definitely choose between two or more assets. So with the help of this method, it helps us to decide which product is worth the price. Next is determine the asset's benefits. So using the calculation of the expenses we have, we can see the estimated cost of the asset that we choose. And lastly is to create accurate budget. Since we already have the breakdown, that's the time we can have the accurate budget of the product. Some of the advantage of this analysis is it will result in earlier actions for the generation of revenue. It also lower the cost than other methods or techniques. It promotes long-term worthwhile. It also provides management awareness of the resources required to be purchased and the drive cost of it. And lastly, this technique will not only focus on the cost but also other factors like the quality of goods and the services that must be provided. And now that we already have an idea what is a life cycle costing, let's now proceed to cost benefit analysis. So it is a procedure for estimating all costs involved and possible profits to be derived from a business opportunity or project. So some of the typical application of this method are greatest return of the cost of implementation, decision making, cost data rational, and verify the cost effectiveness. So for this slide, the steps involved in performing cost-benefit analysis are as follows. First is to identify costs and benefits. Second is to assign values to costs and benefits. Third is to determine cash flow. And lastly is to assess project value. For example, is we have a new software. So by that, we need to list down the cost expenses that we may have for this new software, and they are actual price of software, cost of installation, user training, and annual maintenance. So despite of the cost expenses, we can also list down the benefits that this software help us. So first is the more efficient business processes, better data management, and better customer information. Cost benefit can also express using this formula. So first is we have the net present value, or also known as NPV, equals to total benefits in present time minus total cost in present time. While for the benefit cost ratio, it is equal to total benefits in present time divided by total cost in present time. Some of the advantages of this method is it focuses on data-driven decision making. It also discovers hidden costs and makes some decision better since we are listing and comparing the cost and benefit of a certain product. And lastly is to provide a competitive advantage. And now we have the unit product cost. So it refers to total cost including initial cost, energy cost, operating and maintenance cost, and salvage value expressed on levelized annual cost per basis per unit product. So unit product cost may be expressed in the terms of levelized annual cost. So levelized annual cost divided by annual production, we can definitely get the UPC. And just to give you an idea, annual production can be different units depending on the type of production. In the calculation of UPC, the levelized annual cost should include all costs including energy cost. So for example, a renewable energy application, it decreases the amount of energy consumption corresponding to a reduction in the unit product cost.
Good day, everyone. In this part of the report, I'm going to discuss how life cycle cost analysis is used in deciding which projects are most economical. So without any further, let us begin. To effectively understand the importance of life cycle cost analysis, let's use it in scenario. A while ago, it was discussed that there are two methods in knowing the life cycle cost analysis, which are levelized annual value and net present value. But for this example, we are going to use the net present value. For example, an electric motor is to be purchased for use in a renewable energy application, and there are three options. Compare the total cost of a standard motor, high efficiency motor, and premium efficiency motor. Use the net present value method for comparison and consider the following data. These three motors, provide the same mechanical output of 45 kilowatt. Second is the efficiencies of the standard, high efficiency and premium efficiency motors are 88, 91, and 94% respectively. The initial cost of the standard, high efficiency and premium efficiency motors are $11,000, $13,000, and $14,500 respectively. And we are expecting that these motors will operate in a 10 years maximum. The motors will operate at 400 hours at a load factor of 65%. The price of electricity is $0.10 per kilowatt hour. The operating and maintenance of these motors are $500 per year. The interest rate is 8%, and lastly, the motor have no salvage value at the end of 10 years period. It means that at the end of 10 years, the value of this motor are nothing. So let's start from the standard motor. Let's determine the total cost or net present value of standard motor. To determine the total cost or net present value of the standard motor, we will determine first the initial cost of the standard motor, which is already indicated in the problem, amounting $11,000. And next is, we will compute for the present value of the operating and maintenance expenses. According to the problem, the operating and maintenance expenses of these motors are $500 annually, and their interest is 8%. By substituting these values, we will get $3,355. And that is the second present values for standard motors. Going to the third present value, standard motor has 88% of efficiency, then its electric consumption is approximately 132,955 kilowatt-hour per year, and the cost of it is $13,296 per year. The present value due to the electric cost is $89,260, and that is the third present value. By adding these present values, we can get now the net present values for standard motor, which is $103,600. By repeating the process, high efficiency motor has initial cost of $13,000. And since the operating and maintenance expenses are all the same for motors, then we will use the computed present value for operating and maintenance expenses a while ago, which is $3,355. That is the second present values for high efficiency motor. For the third present values, with an efficiency of 91%, the high efficiency motor accumulated 128,572 kilowatt-hour per year of electricity consumption with the cost of $12,857 per year. The present value due to electricity cost is $86,270. That is the third present values for high efficiency motor. Again, by adding these present values, we will get the net present values for high efficiency motor, which is $102,600. That is the total cost for high efficiency motor. Lastly, the premium efficiency motor. The initial cost of a premium efficiency motor according to the problem is $14,500, a bit higher than the other motors, with the same maintenance and operating expenses. For the third present value, the efficiency of a premium efficiency motor is 94%, which is higher than all motors. That will give us 124,469 kilowatt-hour per year of electricity consumption with the cost of $12,447 per year. The present value due to the electricity cost is $83,519. Adding these present values, we will get $101,400 for the net present value of the premium efficiency motor. Since we already get the total cost or net present value of each motor, we can now proceed to the comparison of each motor to determine which is most economical. In standard motor with an efficiency of 88% has an initial cost of $11,000, is the lowest of all the motors, but the total cost is the highest among all the motors. Meanwhile, the premium efficiency motor with an efficiency of 94% has an initial cost higher than all motors, but the total cost or net present values are the lowest among motors. In conclusion, even though the motor's initial cost is cheaper, it doesn't guarantee us a lower cost for the project. Instead, it might suffer our budget in the long run. So better to choose the higher cost but efficient. That is why the life cycle cost analysis is important to determine the most economical and optimized for our project. Life cycle cost analysis will not only consider the initial cost but the throughout cost. The next topic is about payback period analysis, which is about the number of years when the investor gets back his investment. In layman's term, ROI, or return of investment. In most renewable energy projects, it is very important to know how long it will take for the investment to pay for itself. This is called the payback period. The payback period should be less than the life of the project, but this does not guarantee a green light for the project. It should be less than the life of the project because it is great. If it is greater than the life of the project, then the investor will not get his investment fully, which can be donated as a loss. But of course, the payback period is not only the consideration in the success of the project. There are a lot of factors in considered too. In today's economic environment, it is difficult to get support for projects whose payback periods are longer than 3 or 4 years. I think it has something to do with the rapid development of technology. Due to the fast transition of technology, sometimes the payback of 3 to 4 years is not enough. Then the lesser payback period is better. So the lesser the payback period, the safer for the investor. However, renewable energy projects also provide environmental benefits, and this may justify longer payback periods. But in case of renewable energy, that is another discussion. Since renewable energy imposes environmental benefits, which will help us in the long run for a healthy environment, then a longer payback period is justifiable. How long will it take for the investment to pay for itself from the savings it provides? So from this formula, the present value formula, we will derive the payback period. The P here is the total amount of investment, U is the annual savings, N is the number of years, and of course the I is the interest. Deriving the N, the number of years, we will get this formula, which we call discounted payback period, because the time value of money was considered. The interest and inflation were considered, and as the time goes by, the value of money increased. And that is the another plus for investors. Sometimes, in engineering application, the time value of money was not considered. Then it can be called a simple payback period, which is just simple investment over annual savings. For example, a renewable energy project is to be applied into a building, which involves a solar photovoltaic system installation and a tram wall construction on the south side of the building. The building is heated by a natural gas boiler in winter and cooled by air conditioner in summer. It is estimated that tram wall will reduce the natural gas consumption by 7,500 term in winter, and the photovoltaic system will reduce the electricity consumption by 50,000 kilowatts hour in summer. The cost of the photovoltaic system and the tram wall are $35,000 and $25,000 respectively, including the materials and labor. And the amount here is already the installation and the initial cost. The unit cost of a natural gas and electricity are $1.2 per term and $0.11 per kilowatt hour respectively, taking the interest rate to be 6%. Determine the discounted and simple payback period for each application. Neglect operating and maintenance costs and the salvage value in your analysis. Since the problem stated that operating and maintenance and salvage value is neglected, we can start now in computing electricity and natural gas savings. For photovoltaic system, the electricity consumption that it can be saved per year is 50,000 kilowatt hour. And the cost of electricity is $0.11 per kilowatt hour. Then the savings per year due to implementation of photovoltaic system is $5,500 per year. On another hand, the tram wall can save 7,500 terms per year at a rate of $1.2 per year. Then the savings due to the tram wall is $9,000 per year. Overall, the savings that accumulated due to the implementation of these projects is $14,500 per year. In photovoltaic system, the cost of installation and photovoltaic system itself is $35,000, and the savings from it is $5,500 per year with an interest of 6%, which give us a discounted payback period of 8.25 years. So we will the investor will wait 8.25 years to get his investment of $35,000. For for the simple payback period, we will get 6.36 years. On other hand, meanwhile, the tram wall has $25,000 for installation initial cost and $9,000 for annual savings, taking the interest of 6%. The discounted payback period is 3.13 years. For the simple payback period, the tram wall will have 2.78 years. For comparison, the photovoltaic system has a longer payback period than the tram wall. The simple payback period underestimates the actual payback period by about 23 months for the photovoltaic system and about 4 months for the tram wall. And that's all. Thank you.